Good evening, students of Class 12. This is Dhanu Saraiya continuing with the chapter 2 of Class 12 with the topic potential, in which we are today deriving potential due to electric dipole. And in the next page of the same video, we shall even find out the difference between the potential due to electric dipole as well as due to a single charge. So keep watching the video till the end so that you understand these two concepts very clearly. Now, as can be seen, there is a electric dipole with a positive charge plus q and a negative charge minus q. Distance between these two charges is 2a, and here we can see the direction of the electric dipole, which is from the negative charge to the positive charge, denoted by p. Here I have a point P whose position vector from the center O of, or the origin of, the dipole, center O can be considered as the origin, and the position vector of the point P from O is R arrow, R vector. R1 is the distance between Q and P. R2 is the distance between minus Q and P. So as usual, I always write down the description of the diagram so that it is easier for you to understand what we are talking about. First, let me write down theta. Theta is the angle between P arrow and R arrow. Correct? Okay. R1, the distance between Q and P. R2, the distance between negative charge and P. And R vector is the position vector of P with respect, point P with respect to O. Okay, this is the description of the diagram as seen. A, here also it is A because the distance between these two charges is 2A, and if O is the center, the upper part O to Q is A and O to negative Q is also A. So this is the diagram which we have taken. Now we want to find out the potential due to electric dipole. So we use the principle of superposition, in which we add the potential due to the individual charges at the point P and add them algebraically. So V is equal to KQ upon R1. This is the potential for plus Q, minus KQ upon R2. Negative I have written because charge is negative here. Okay, so minus KQ upon R2 for the negative Q's potential. So I take KQ common and write 1 upon R1 minus 1 upon R2 in brackets. So this is the potential due to the dipole. Fine. Now, once this is calculated, we have to understand what is the value of 1 upon R1 and 1 upon R2, because that is not given to us. That is simply one point we have taken whose distances are R1 and R2 from plus Q and minus Q. So now we will try to find out an expression for 1 upon R1 and 1 upon R2. Clear? And substitute it here, and let me name this as equation number 1. Another condition I have taken, R is much greater than A. What is the meaning of R much greater than A? The point which we are considering is much far compared to the distance between the two charges of the dipole, plus Q and minus Q. Fine? Okay. So now let us do a construction in which we have dropped a perpendicular on the position vector R arrow from plus Q to R arrow. Then we further extend the position vector and again drop a perpendicular from minus Q to R arrow. Okay, so this is also a right angle. Now, as can be seen, if theta is here, then theta is here also, vertically opposite angles. This is A and this is A. Therefore, this portion is A cos theta according to trigonometry. This portion is also A cos theta. Fine. In these two triangles, as can be seen. Okay. Now, using the condition R much greater than A, we can write R1 nearly equal to R minus A cos theta from the diagram, and R2 nearly equal to R plus A cos theta from the diagram. Now we go to the diagram and understand how did I write this. R1 is equal to R till O minus this portion A cos theta. That's why I have made the construction. Okay, here we can say these two sides are nearly equal and this portion from here to here is R minus A cos theta. Similarly, in this triangle, longer triangle, we can write R2 nearly equal to R plus A cos theta, which I have written here. Fine. Okay. Now, I am trying to reach here 1 upon R1 and 1 upon R2. So, I will do the maths on R1 and we will try to find it out for R2 also accordingly. So, I am just squaring R1 on both the sides. Okay, I have squared both the sides. Fine. Okay. So, R square plus A square cos square theta minus 2AR cos theta. Now, after squaring, I take R square common. So, I get in the bracket, here if I take R square common, I get 1. Here I get A square upon R square because I have taken R square common. Minus 2AR upon A square, sorry, R square because I have taken R square common. Okay. Now, here because R is much greater than A, I can neglect A square upon R square terms. That is, this term I can neglect. Why? Because this value is going to be very small and cos takes the value from minus 1 to 1. So, overall this term can be neglected. Fine. And this I cancel and this also I do. So, what do I have? R1 square is equal to R square 1. Neglecting this term, negative 2A upon R cos theta. So, I have this much. What did I do? I just squared it and removed the central term. Now, taking the reciprocal on both the sides, we have 1 upon R1 square is equal to 1 upon R square, and this term I am writing as a power of minus 1, taking it as reciprocal. Now taking square root. Now this, what did I do? Reciprocal. Okay. Now this step, what am I doing? Taking the square root. Okay. So if I take the square root, I get 1 upon R1 nearly equal to 1 upon R and 1 minus 2a upon R cos theta whole raised to negative half. Now I use binomial expansion where this power can be multiplied in the center of the term and I get 1 upon R1 is equal to 1 upon R 1 minus negative is there in the center here. Again taking negative half and writing 2a upon R cos theta. Okay, so here 2 and 2 cancel. So I have 1 upon R1 is equal to 1 upon R brackets 1 minus minus plus a upon R left out cos theta. Fine. Okay. Now continuing the same maths, I will also get 1 upon R2 is equal to 1 upon R 1 minus a upon R cos theta. Now here I have a positive symbol. So here I will have a negative symbol. Everything else will be the same in 1 upon R2 compared to 1 upon R1. The symbol changes from here itself. Here minus and here plus. That's why R1 has center plus and R2 has center minus. So I have got the value of 1 upon R1 and 1 upon R2 which I can substitute here. Okay, so I will substitute here, but you just take a pic of what we have done just now so that I go to the next page and continue the derivation. Fine? Okay. Please take a pic. Then we can go to the next page. Now going to the next page, I rewrite what we want to do. I will write again what we got for 1 upon R1 also. And 1 upon R2 also. 1 minus a upon R cos theta. Okay. Now I substitute both these values in equation 1. I get for 1 upon R1, 1 upon R, 1 plus a upon R cos theta minus, this is for 1 upon R2 now, 1 upon R, 1 minus a upon R cos theta. Just doing a normal maths. Opening the brackets. As can be seen. I am left out with 2a upon R square cos theta in the bracket and take you outside. So this is my V. Now I can write it further as K Q 2a Q 2a clubbing these two. And if you remember, this is the magnitude of the electric dipole moment itself. upon r square. Fine. Now cos theta is there here, which means it is a scalar product. V is a scalar product of two vectors. So we write the scalar product of the two vectors as Kp cos theta upon r square, where P is equal to K into 2A, one of the charge multiplied by the distance between them. Here I can substitute P cos theta is equal to P arrow dot r cap, where r cap is a unit vector of the position vector from O to P. So I can write V is equal to K P arrow vector P dot r cap for P cos theta divided by r square. Fine. Okay. So this is the formula for potential due to electric dipole at a point P. Fine. Okay. Now here in the formula I have a cos theta. So let me take theta is equal to 0. Cos 0 is 1. So what do I have? V is equal to Kp upon r square. Let me also take theta is equal to pi. That means theta is 180 degrees. What is cos 180 degree? -1. What is cos 0? 1. So what can I get the formula for potential as? V is equal to cos 180 is -1. So negative Kp upon r square. So whether this or this or this formula with changing theta, I have V directly proportional to 1 upon r square, or potential is inversely proportional to r square, and it is depending upon theta also. Clear? Okay. Now what I have done is theta is equal to 0 and theta is equal to pi. I will go to the diagram and show you again, but till then you take a pic of what calculation we have done just now for the potential. Fine. We will understand how to take theta is equal to 0 and theta is equal to pi. Fine. What about theta is equal to pi by 2? What will I get? What is cos pi by 2? Cos 90? 0. So what will be my V? V is equal to 0. These all are 1 markers which are going to be asked in your entrance exams. So remember the formula, understand what is theta given to you, substitute the value. Now all these three conditions I will show you in the diagram. So we go back to the diagram. Okay, what is it? I said theta is equal to 0. What does it mean? That this vector is taken upwards. Fine. Okay. So for theta is equal to 0, this vector r is taken upwards. Fine. So that r becomes aligned here, r arrow. So that p arrow and r arrow angle theta is between p arrow and r arrow, theta is equal to 0. And for theta is equal to pi, how do I take? I take this vector downwards. So this will become r arrow, angle of p arrow is up, r arrow is down, vector p arrow up, vector r down. So what is theta here? Pi, 180 degree. Third condition, theta is equal to 0. How will I go? Like this. R vector. P vector up, R vector perpendicular to it. Therefore, theta is equal to pi by 2, 90 degree. Agreed? So, if P is here, theta is equal to 0 and the potential is Kp by r square. If P is here, point P is here, theta is equal to 180 degrees. Formula of potential is negative Kp upon r square. And if the point P is here, perpendicular, then theta is equal to pi by 2. Potential is 0. This also can be a question where they can show you plus q minus q, P is vertical and point P is here, point P is here, point P is here. We can make our own questions. Physics is such a subject. Then in this case, theta is 0. In this case, theta is pi. In this case, theta is pi by 2. Now, they can be even trickier than this. Now we have learned for plus q up and minus q down. They can put minus q, negative q up and positive q down. You have to understand the logic. What will happen in that case? If negative q is up and positive q is down, then what is the direction of P? Electric dipole direction is downwards. Then this will be theta is equal to 0, this will be theta is equal to pi. So be very careful whenever diagrams are there. Keep your eyes open and understand the question very clearly so that you understand what they are asking and what they are telling. Fine? Okay? So I'll just move. You take a pic of what I have done just now also. Then we will go to one more page where we find the difference between potential due to a dipole and potential due to a single charge. Take a pic. This pic already I have taken, but here I have made the angles now. Other part is already done. Only near the diagram, what you can do or what you can understand, that you see. Fine? Okay. Now, I go to the next page where we find out difference between a point charge and a dipole's potentials. What is the formula here for a point charge? V is equal to KQ upon R. Here what did we get? V is equal to Kp cos theta upon R square. Or we also wrote it as K P arrow dot R cap upon R square. Okay. Here V inversely proportional to R. Here V inversely proportional to R square. Here no dependence on theta. Here depends on theta. Fine. Okay. So these are the differences which you can easily understand and write down. Okay. So they can ask you, or they can ask you to compare, or they can put it as a question also. Fine. So note down this. I just move. You take a